Hey everyone, welcome back to the Tensorflow for NLP tutorial series. In the last video, what we did is we created a new type of preprocessing for our sequences so that now we can handle sentences instead of just word pairs. In this video, what we're going to do is we're going to start creating the labels for our sentiment analysis classifier by looking at the reviews and trying to extract the star ratings. And so we're going to take only the reviews that are most positive and label them as positive, and take the reviews that are negative and label them as negative. So to do that, we're going to use pandas, but first what we're going to do is we're going to alter our original word-to-vec file, and we're going to add a couple more imports. So we're going to say from keras.utils import to categorical, from keras.preprocessing import preprocessing.sequence import skipgrams and pad sequences, and from random import shuffle. We might not use all these today, but we'll get to them eventually, and they're going to be used in creating this new model. So the first thing I'm going to do is I'm going to take this and I'm going to kind of change this. Maybe we'll cut it off at 30,000. Now that we're not doing the word pairs, this data constraint will be a lot more forgiving. So we're not going to be just taking a bunch of pairs from each sentence. What we're going to be doing is actually processing each sentence as itself. So it'll be a little bit more forgiving on memory usage. So the first thing we need to do is we need to extract these labels. So to do that, we're going to say df label, and what this is going to do is going to create a new column in our data frame called label, and we're going to say that's np.where df.overall is greater than or equal to 3. We're going to say it's 1, and if it's not, it's going to be a 0. So what this is doing is we're saying take our data frame and get this overall column. So this overall column is actually our star ratings. And where that overall is greater than or equal to 3, we're going to label that as positive, so that'll be 1. And where it's not greater than or equal to 3, so 1 or 2, it's going to be 0. And that's what this label column is going to be inside of our data frame. After that, what we're going to do is we're going to get a numbtosample. So basically, what we're going to have to do is we're going to sample only the same amount from each class. So if we have a ridiculous amount more positive reviews than we do negative reviews, it might affect our classifier. So we're going to try to split each sample equally so that we have the same amount of positive reviews as we do negative reviews when we go to train the model. So we're going to say num_tosample equals the length of df where df.label equals 0. So I found that in this data set there was a lot less negative reviews than there were positive reviews. So we're going to say get the amount of negative reviews that we have, and we're going to extract all of them, but we're going to have to sample the positive reviews to this same amount num_tosample. So number of the smaller class, I'm going to say negative reviews. Okay. And now we actually have to go ahead and sample both of those. So we're going to say df neg equals df label, and we're going to say where that equals 0. So those are the negative samples, and then we're going to call the pandas method sample. So we're going to say dot sample, and basically what this is going to allow us to do is grab a random sample of that amount of reviews. So I guess this is probably not necessary because, you know, we're grabbing all of these, so whatever. And the positive is going to be the exact same as this, except for now we're going to say where this label is 1, because again, it's wherever this is greater than or equal to 3, and we're going to sample the same amount. Okay, and now we're going to go ahead and recreate our data frame with the concatenated version of these two put together. So we're going to concat those on top of each other, and we're just going to pass this a list. So df neg, df pause, and boom, now we have our negative and positive samples in one data frame together with an equal amount of both classes. And now we can get the text, which I believe is the same here. Yep, okay, so we're gonna have the same text. And now we're gonna create our labels. So create labels from the data frame. And we're gonna say labels equals df label. And we're gonna say dot values. So just like we did here, we're gonna get the NumPy list of the labels. And perfect. So in the last video, we created that data helper library that is going to allow us to tokenize and process our text. So now we're going to use that. So make sure you have it imported up here. So import data helper. Or you could just put that function right inside here, but I did it just to make it look a little bit cleaner, even though it doesn't look so clean. We're going to say that data word to IDX, IDX to word, and t equals data helper dot tokenize and process. And we're going to pass it our text. And we're going to set a vocab size. So vocab size equals vocab size. We haven't created this variable, but I'm going to create it right now. And let's get rid of these 2 lines because this is from the old data helper library. So get rid of those 2 lines. Okay, actually what we can do is we can really take everything from down here. So where we created these, we're going to leave these here for now. But everything else we can just take out. So let's take out everything all the way up until what we just did just now, which is a little scary, but we're going to take it out. And boom, there we go. I'm actually going to cut this, and I'm going to place this underneath some of these variables we created. So again, I just created this vocab size variable, and now we're also going to say vocab size. Wow, that's a really bad comment. And we'll limit it to 20,000 for now. All right, and now that we have that, we're also going to add a few more other import statements, or not import statements, but variables. So we're going to say LSTM number of hidden units. We say LSTM hidden units equals 256. And I'm going to explain these a little bit more later, but we'll just leave this for now. Number of classes equals num classes equals, and I want you to go ahead and guess what it's going to be. It's going to be 2. All right, you didn't have a lot of time to guess on that one. And we're going to say sequence length. And I'm going to change this comment so it's not so terrible. So number of words in each of our sequences. And I think we have everything. I'm going to change this embedding size to 256. Okay, now that we've called to our pre-processing file, we're going to pad the sequences. So we're going to take the data that we got out of our pre-processing file, which is this data right here, and also our labels, and we're going to get them in the correct format for our model. For the data, what we're going to do is we're going to pad the sequences, which is basically going to add leading or trailing zeros and make every single sequence be the same size. And our labels, we're going to turn into categorical variables, which will be like one hot zeros and one. So it'll be a vector that's of the length of the same number of classes. So it's going to be 2, the length of 2. And so positive labels would look like something like this, maybe. And then negative would be the opposite, so it'd be 0 and 1. So that way our model will be able to understand it a little bit better, and it's going to work a little bit better if we do it this way. And then for the padding of the sequences, maybe the original sequence would be something like, I don't know, some random amount of integers, and then our padded sequence would have leading or trailing zeros. And I think what we're doing here is leading, so we're going to have a bunch of zeros maybe, dot, 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 slash 0, and then we would have these here. And the reason you pad the sequence is that it allows our model to know that the sequences are always going to be the same size, and that it's not expecting some variable size, so it doesn't have to correct for that. And what you're going to find is that your model will be more accurate if you have sequences that are all the same size. So that's what we're going to do, and that's why we imported these things up here. So one thing that we're going to do for the labels is to turn them to categorical, and then we got pad sequences here from Keras as well. So to do this, we're going to say data equals pad sequences with our data, and then you set a max length equal to the sequence length. So that is the variable we set right here. So now every single review that we have is going to be turned into a vector that is length 250. So if it's shorter than 250, it's going to pad it with extra zeros until it's the length of 250. And if it's greater than 250, it's going to get cut off at 250 integers. And likewise, we're going to, well, not likewise, but we're going to create labels, and we're going to turn this to categorical. Categorical, okay, I spelled that right. I'm going to say labels, and then we're going to say num classes equals num classes. And again, what that's going to do is it's going to create a different format for our labels so that our model can accept it a little bit better. Okay, so we're at an exciting point now. We have our data, and we have our labels all ready to go to be used in a model that will classify if a given review is positive or negative. In the next video, we're going to talk about the LSTM from a high level, so you guys don't get bogged down in the details too much, but you still have an intuitive understanding of how sequence models work. And we'll also build that model. So I hope this helped, and if you have any questions, please let me know. As always, thanks for watching, and I'll see you next time.